Hi, fifth grade. Today we're going to be doing module 4, lesson 14, and we're going to be continuing with the multiplying fractions by fractions for this lesson. So previous problems that we've had, we might have done like 1/3 of a half, and then we'd show a model to show what 1/3 of a half is, and then eventually get like 1/6. So these have been the problems that we have been getting so far, and our numerators are usually really easy to work with because they're mostly just have been 1. But now with this lesson, what we're going to be doing is we're going to be getting different types of fractions, and we're eventually going to be having to simplify as well. So we're going to be mixing up a little bit more of what we know about fractions into this lesson. So for our first problem, we have a word problem, and it says Jan had 3/5 pan of Rice Krispie treats, and she sent 1/3 of the pan to school. What fraction did she send? So if I'm looking for the important information in this, I know that 3/5 pan of rice is important for me to know, and that she sent 1/3 of this. So these problems are very similar to the ones from the previous lesson, just different types of fractions. And I'm trying to figure out how much did she send. So I know that she sent 1/3 of the, she sent 1/3 of 3/5. So she made 3/5 of a pan, and then she sent 1/3 of that to the school. So 1/3 of 3/5. Now remember, this of part is the same thing as multiplication. So when I say 1/3 of 3/5, I can also say 1/3 times 3/5. And now to solve this, I'm going to show you a model, and then we can also do it numerically. So when I do my model for this, I'm going to first start off by just drawing my area model, and then I'm going to, since the third is the first fraction, that's what I'm going to cut my area model into first, is thirds. So I'm going to cut it into thirds like this, and then I'm going to shade in this area right here. So I shade in that area, and then I need to cut it into fifths because that is what my second fraction is. So I have to cut this into fifths so that I have totally equal parts. So I cut it into fifths, 2, 3, and 4. But this is where things get different because most of the fractions we've done before would have been like 1/3 of 1/5. But now we have something that's different. We have 3/5. So now I have to think about, okay, I have 1, 2, 3, 4, 5 fifths in total in this model. I need to shade in 3 of these fifths because there is a 3 in my numerator. So to do that, just like we did in the previous lesson, I go over. So that is 1/5, and if you need to, count out loud to yourself as well. So I have 1/5, 2/5, and 3/5. Sorry. And what we have right here now is the answer to our problem, because I just have to look at this and I have to see, all right, now which boxes have both of these colors or have overlaps when I multiplied and did my model. And I only have 1, 2, 3 boxes that actually overlap. Remember, the rest of these boxes don't really matter because they only have one color. The ones that have both of the colors are the ones that matter. So I have 1, 2, 3 boxes. So that means that my numerator is going to be 3. And then my denominator, remember, is the total of boxes that are in my model, or the total units that are in my model. So I have 3 by 5, so that I know that 3 times 5 is 15. And then my answer technically is 3/15, but I know that I should always check to make sure that my fractions are simplified. And this fraction is not simplified. So I need to think about, all right, so anyway, so for 3/15, I know that that is something that I can simplify. So what I'm going to do is I am going to think about what factor could I possibly divide both 15 and 3 by. Well, my answer is pretty easy right now because I look at 3 and I think, okay, I can do 3 divided by 3, and I can also do 15 divided by 3. Because remember, way back when we said whatever you do to the bottom or to the top, you have to do to the other side. So I'm going to divide both of these by 3. and then I'm going to get my simplified fraction. So 3 divided by 3 is 1, and then 15 divided by 3 is 5. So my final answer for this problem is 1/5. Now, unfortunately, when you're doing the models, you can't really get the simplified answer out of that. So what you need to do is that once you have the answer, like the 3/15 from your model, then you have to check and think about what factors can I divide this by, and then get your final answer. So that's how some of these problems are going to work. So make sure you're thinking about those factors as you're doing the problems. I'm going to set up the next word problem on the board. So I'm going to pause real quick and make sure that you're getting all this work down as we're doing this. Oh my gosh. Okay, so for our next word problem, it says that Jan has 3/4 pan of treats and she sends 1/3 to school. How much did she send? So my first step in this problem is going to be to identify the important information. So I have 3/4 of a pan that she is sending, or that she made, and she sent 1/3 of that to school. How much did she send? So when I do this problem, I now need to start with, well, she brought 1/3 of 3/4 pan to school. And remember, I could think of this of parts as a multiplication problem. So now what I need to do is I need to draw my model. And to draw my model, I'm first going to draw my model like this. And then I'm going to start with my first fraction. My first fraction is 1/3. So I'm going to break my area model up into thirds vertically. So I draw my lines like this. And now I split my model into thirds, and I need to shade in one piece like so. So I shade in 1/3 just like that. Now with my other color, I am going to show you 3/4. So since my denominator is 4, that means I need to cut horizontally my model into fourths. So I'll do that. And now that I have all those parts cut up, I now need to shade in 3 of those fourths. Remember, we have 1/4, 2/4, 3/4, and 4/4. 3 of these fourths needed to be shaded in. So I'll do that. So I shade in all the way across like so. And now my final step to solve this problem is I need to count all the boxes that have both colors in them. So I have 1, 2, 3 boxes that have both colors. So I will then write this as 3 over, and now I need to figure out what my denominator is, and that is the total amount of boxes or units that I have. And I can easily do this. I don't have to count each individual box. What I can just do is count 1, 2, 3, and then multiply it by this side. So 1, 2, 3, 4. So 3 by 4 is 12. So we have 3/12. Now remember though, this is not my final answer, or it may not be my final answer, because I had to figure out if there's anything that I can divide both 12 and 3 by. And this is where it's important that you know your facts. So for 3 and 12, I know that I can find my LCM between these two. So remember, if you can't do it in your head just yet, then you can list out your multiples and find that least common multiple. So I did an example for 4/8. So I listed out the multiples of 4, 1, 2, and 4. And then for 8, I listed out the multiples of 1, 2, 4, and 8. Since 4 is the greatest number that I am finding the numbers that they can both be divided by. So then for 3/12, I need to divide. I need to find their factors. So I can have 1 and 3, and then for 12, I can have 1, 2, 3, 4, 6, and 12. And now I just have to find the number that matches, which is my 3. Remember, 1 doesn't count. I find that 3, and that tells me that I can divide both of these by 3, just like that. So I do 3 divided by 3, which gives me 1, And then I do 12 divided by 3, which gives me 4. And my final answer for this problem is 1/4. So that's all we need to do for these. Now, for these problems, we're going to try one now where we just do it numerically and with the model. So let me erase this real fast. And please make sure you're getting all of this work down. Now, for our next problem, we have a half times 4/5. So there is no word problem for this one, but I am going to draw a model and then do it numerically. So for this one, I'm going to start off with having my model. I'm going to cut my model in half vertically and then shade that part in. And now, since my second fraction is split into fifths, has a denominator of 5, I'm going to split this into fifths like so. 2, 3, and 4. So now I have 1/5, 2/5, 3/5, 4/5, and 5/5. And since I have 4 in my numerator, that means I need to shade in 4 of these spots. So I'll shade in 1, 2, 3, and 4. And then I'll get my answer from this. So I have to figure out which boxes have both of the colors in it. So I have 1, 2, 3, and 4. So my numerator will be 4, and then my denominator is the total amount of boxes in my area model. So I'm going to, instead of counting all of it, I'm just going to go 1, 2, so I know it's going to be 2 times 1, 2, 3, 4, 5. So I have 2 times 5, which gives me 10. But remember, we want to make sure that we are simplifying our fractions. So 4/10, I can simplify 4/10 by 2 because I know that I can divide both 4 and 10 by 2, and that's the biggest number that I can simplify them by. And I made a little oops in the last problem. I should have said GCF, because that you're finding the greatest common factor. LCM is when you are trying to get those equivalent fractions. So that's my bad right there. So again, if I were to list out the factors, I could have 1, 2, 4, and 10 would be 1, 2, 5, and 10. This is the biggest number that matches, so that would be what I can divide both 4 and 10 by. And then when I get to this part, now I can simplify this. So I have 4 divided by 2, which gives me 2, and then 10 divided by 2, which gives me 5, and my answer is 2/5. Now, you may have noticed so far that a lot of the time, whatever my second fraction was, like my second fraction was 4/5, my answer is usually also going to be in fifths. So I had 4/5, now my answer is 2/5. So usually you'll know if you got something right if the denominator is the same. It's not always going to be like that, but that could help you out. And most of the problems in the problem set so far, you are going to have to simplify. So just know that you should always be looking out for that. I'm going to pause the video and get the next problem up and keep up the good work. All right, so for this problem, 5th grade, we have a word problem again. And this one says that 3/4 of Ben's garden is vegetables. Carrots are planted in half of this section. So how much of the garden has carrots? So I'm going to go find the important information for this problem. So 3/4 is vegetables, and then carrots make up half of that section. So how much of the garden has carrots? So I am finding half of 3/4 right now, because half of the 3/4 is carrots, and I'm trying to figure out what that means. So I can always change that of to a multiplication sign. And real quick, I keep saying I'm going to do the numerical part, but I haven't yet, so I'm going to do that now. So when I do the numerical part, it's just like all the multiplying fractions that you've done so far. All you need to do is just go straight across and multiply, and that's all you need to do. So I'll do 1 times 3, which gives me 3, and then I do 2 times 4, which gives me 8. And then I'm going to think about those multiples of 3 and 8 and see if this needs to be simplified at all. So 3 would be 1, and 3. 8 would be 1, 2, 4, and 8. I don't have any matching numbers other than 1, so we actually got lucky with this problem, and we don't need to simplify it at all. I'm going to show what this would look like as a model, though. So for my model, I will first be splitting this into half, because that is what my first fraction is. So I split it in half like this, and then I have 3/4. So I know that I have to split my model horizontally into 4ths. So I'm going to cut it like this. And then I need to fill in 3 of those spots. So I have 1/4, 2/4, and 3/4. And then I get my fraction from my model. So there are 3 spots, 1, 2, 3, that have been colored in with both colors. So then I have 3 filled in, and then I have to figure out how many total boxes are there. So I have 1, 2, by 1, 2, 3, 4. So a 2x4 model will give me 8. So 2 times 4 is 8, and that gives us our final answer of 3/8 as well. And that's all we have to do for this one. Then we're going to move on to our very last problem, and this is something that I would like you to try on your own. So I'm going to erase this. And for your last problem, you're now finding 3/4 of a half. 3/4 of half. So you're going to be trying to solve this one. Remember, you just go straight across, and I think you should have an easy time with this one. So go ahead and try it out. And I'm going to try solving this one as well now. So for this one, we want to make sure that we put in that multiplication symbol. And then if I'm doing this numerically, I can just go straight across. So I'll do 3 times 1, which again gives me 3. And then I'll do 4 times 2, which gives me 8. And look at that. The commutative property gives me 3/8 again. So nice, easy problem for you. Now, for your problem set today, what you're going to be doing is number 1, A through F, so that whole first page. And then you're going to do word problem 3, and this is a 2-part word problem. So you're going to do word problem 3, parts A and B. The other word problems you don't have to do unless you would like to get extra practice. Then for your homework tonight, you need to do number 1, A through F. So again, that whole first page. And then word problem 2. Since word problem 2 says that you need to draw a model, I would like to see a model for your answer. Don't just do it numerically. I know that that's very easy to do, but I also want to see your models when you get to those problems. All right, if you need any help, please let me know, and then good luck.